In the heart of East Africa's Great Rift Valley lies Lake Natron, a shallow salt lake straddling the border between Tanzania and Kenya. This striking body of water is nestled within a landscape shaped by ancient tectonic forces, where the Earth's crust has been pulled apart over millennia, creating a dramatic rift that stretches across the continent. Its waters glow with surreal reds and pinks, a result of unique chemistry and microscopic life thriving where little else can. The vivid colors are produced by salt-loving microorganisms and algae, which flourish in the lake's alkaline waters, painting the surface with hues rarely seen in nature. The lake spans nearly 600 square miles, yet is rarely more than 10 feet deep. Its shallow waters are bordered by brilliant white salt crusts, and the entire scene is dominated by the looming presence of Ol Doinyo Lengai, an active volcano revered by the Maasai people as the Mountain of God. The air here is thick with heat and minerals, shimmering with mirages under the relentless sun. The landscape feels otherworldly, primal, silent, and raw, as if untouched by time or human hands. At first glance, it appears utterly inhospitable, a deadly trap for most creatures. The caustic waters can burn skin, and the high temperatures and mineral content make survival seem impossible. Yet, beneath this harsh exterior, Lake Natron is a sanctuary for life that has adapted in remarkable ways. Here, flamingos gather in the thousands, and specialized organisms thrive where few others dare to venture. In this extreme environment, the rules of biology are pushed to their limits, making Lake Natron a natural laboratory for survival and adaptation. Every living thing here tells a story of resilience and ingenuity. To truly understand this place, we must look beyond its striking beauty and explore the chemistry, geology, and extraordinary animals that call it home. Scientists from around the world come here to study how life endures in such a hostile setting. This is the story of one of Earth's most extreme and vital ecosystems, a crimson jewel in the heart of the Great Rift Valley, where life finds a way against all odds. Lake Natron's danger lies in its chemistry, a potent mix of minerals that creates a hostile environment for most life. This is not just any ordinary lake, it's a natural cauldron where the elements combine to form a landscape as beautiful as it is deadly. The very air above the water shimmers with heat, and the ground crunches underfoot with sharp, mineral-laden crusts. Its water is highly alkaline, with a pH near 11, and nearly twice as salty as the ocean. The caustic water can burn skin and eyes, and the salt content is so high that it leaves thick white deposits along the shore. Even the air carries a faint acrid tang, a reminder of the lake's chemical intensity. The lake's endorheic nature means water only leaves by evaporation, concentrating salts and minerals over millennia. With no rivers to carry minerals away, every drop that evaporates leaves behind a little more salt, making the water denser and more inhospitable with each passing year. Temperatures soar above 42 degrees Celsius, making the lake a simmering pan under the equatorial sun. The relentless heat accelerates evaporation, intensifying the already extreme conditions and turning the lake into a crucible for life. This combination of high alkalinity, hypersalinity, and heat forms a chemical barrier few organisms can cross. The lakebed cracks and splits under the sun, and the landscape appears almost alien, hostile to all but the hardiest forms of life. The vibrant red hue is a warning, produced by halophiles and cyanobacteria that thrive in these conditions. These microorganisms not only survive but flourish, painting the water in shades of crimson and orange, signaling danger to would-be intruders. These microorganisms form the base of a specialized food web, defying the lake's deadly reputation. They provide nourishment for the lesser flamingos, whose very survival depends on this harsh ecosystem. For most creatures, the water is a weapon, but for a select few, it's a haven. The same chemistry that calcifies the remains of the unwary also protects the flamingos from predators, creating a sanctuary in the midst of danger. Lake Natron's chemistry is both a barrier and a foundation for life. It draws a sharp line between those who can adapt and those who cannot, shaping a unique ecosystem found nowhere else on Earth. Here, survival means adaptation on a molecular level. Only the most resilient species endure, evolving remarkable strategies to thrive in a place where danger and beauty are inseparable. Lake Natron's origins are written in the geology of the Great Rift Valley, where tectonic plates slowly pull apart. The lake's basin was formed by rifting and volcanic activity, with Old Doinyo Lengai volcano dominating the landscape. This volcano is unique, erupting nitrocarbonatite lava rich in sodium and potassium carbonates. Ash and debris from eruptions wash into the lake, fueling its extreme alkalinity. The lake is geologically young, about 10,000 years old, created as the Rift Valley sank, and water collected in the basin. Rain and rivers dissolve minerals from volcanic soils, feeding the lake's chemical transformation. The region remains dynamic, with ongoing tectonic movement and volcanic activity shaping the lake's chemistry. Geologists study Lake Natron as a living example of continental rifting and the birth of new landscapes. It is a geological marvel, shaped by the restless forces beneath our feet. Lake Natron, nestled in northern Tanzania, is infamous for its petrified animals, birds and bats preserved in eerie statue-like forms along its desolate shores. The sight of these calcified creatures, frozen in time, has inspired both fascination and fear, fueling rumors of a lake that turns animals to stone in an instant. The myth of instant petrification is exaggerated, but the reality is still chilling. The process is not magical, but a slow, relentless transformation driven by the lake's extreme chemistry. Birds, often confused by the lake's mirror-like surface, may mistake it for a safe landing spot. Once they touch down, the caustic water quickly incapacitates them, making escape nearly impossible. The high concentration of sodium carbonate and other minerals in the water acts as a natural preservative. As the water evaporates under the scorching sun, the bodies become encrusted in thick mineral layers, preserving them in haunting detail. These calcified remains serve as a stark warning of the lake's unforgiving chemistry, a visual testament to the dangers lurking beneath its surface. Only animals uniquely adapted to these harsh conditions, like the lesser flamingo, can survive and even thrive here. For others, the lake is a deadly trap, claiming the lives of the unprepared. The phenomenon is a side effect of the lake's unique properties, its high alkalinity, mineral content and extreme temperatures, not a supernatural curse as some believe. Healthy local birds have learned to avoid the danger, but the unlucky or unadapted, drawn by the lake's deceptive beauty, fall victim to its deadly embrace. The preserved carcasses highlight the sharp divide between life that has evolved to flourish here and life that cannot withstand the lake's harsh reality. In the end, Lake Natron's deadly illusion is not just a spectacle, but a natural defense, protecting its fragile ecosystem by keeping out those who are not meant to survive. Paradoxically, Lake Natron is the world's most important breeding ground for the lesser flamingo. 75% of the global population is born here, on mudflats surrounded by caustic water. The lake's hostility protects flamingo nests from predators, creating a natural fortress. Flamingos build volcano-shaped mud nests to keep their eggs above the alkaline water. The spectacle of millions of flamingos nesting together is one of nature's wonders. The lake's cyanobacteria, spirulina, thrive in the alkaline water and provide food for the flamingos. Carotenoid pigments in spirulina turn the flamingo's feathers brilliant pink. Lake Natron's toxicity is the secret to the flamingo's survival and color. Flamingo chicks hatch into a world of danger, covered in gray down and reliant on their parents' care. Parents feed them crop milk, a nutrient-rich secretion, allowing rapid growth in harsh conditions. As they grow, chicks gather in massive creches for warmth and safety, watched over by a few adults. This communal strategy confuses predators and increases survival odds. The greatest challenge comes when chicks must trek across salt flats to reach freshwater springs. The journey is perilous. Sharp salt crusts and incrustations can trap the weakest chicks. Only the strongest survive the march, reaching fresh water to drink and clean their legs. Here, they continue to grow, shedding down for flight feathers. The harshness of Lake Natron forges resilient new generations. Survival here is a test of endurance from the very start. Flamingos aren't Lake Natron's only survivors. Meet the alcalapia, a fish found nowhere else on Earth. Over millennia, alcalapia have evolved to thrive in the lake's alkaline, salty, and hot waters. Specialized gills and kidneys help them excrete excess salts and maintain pH balance. They seek cooler water near springs and can gulp air when oxygen runs low. 3 distinct morphs have evolved, each with unique mouth shapes and feeding strategies. Alcalapia alcalica is a generalist, feeding on algae and insects. Alcalapia latulabris and Alcalapia ndara are rock grazers, scraping tough algae from hard surfaces. These adaptations allow them to exploit every available niche. The Alcalapia's story is evolution in action, diversity born from adversity. Lake Natron's fish are living proof that life can adapt to the most extreme environments. Lake Natron is a natural laboratory for scientists, offering insights into evolution, climate change, and planetary geology. Studying its flamingos and fish reveals how life adapts to extreme conditions, knowledge vital as global waters become saltier. The lake models how species might respond to future environmental shifts. For geologists, the region showcases continental rifting and the birth of new landscapes. The lake bed preserves a fossil record, including a mass die-off of Alcalapia, revealing moments in evolutionary history. Astrobiologists look to Lake Natron as an analog for life on other planets, where extreme chemistry might still support microbes. The lake expands our definition of habitability, guiding the search for life beyond Earth. Lake Natron is a key to understanding both our planet's past and its possible futures. Lake Natron is a testament to life's resilience and adaptability, challenging our ideas of beauty and survival. It's a landscape of extremes, death for some, sanctuary for others, where nature's rules are rewritten. The interconnected web of volcano, lake, flamingos, bacteria, and fish is a masterpiece of coevolution. Preserving such unique places is vital. They are living libraries of Earth's story. From calcified birds to vibrant flamingo colonies, Lake Natron is endlessly fascinating. It teaches us to look beyond the surface and appreciate life's ingenuity. Even the harshest environments can become cradles of life with the right adaptations. The crimson jewel of the Rift Valley endures, a symbol of nature's power to survive and inspire.